Thank you for tuning into the Secure Your Energy Show. I am your host, Michael Gibson. The Secure Your Energy Show is where we have real life conversation with real life people. And today we have a very special guest from Northern Arizona Wind and Sun. His name is James Hall. I'm bringing him onto the screen and let him introduce himself. James, thank you for joining us today.
Yeah, thanks, Michael. Yeah, so this is my name's James. I'm with Northern Arizona Wind and Sun. I'm one of the application engineers here. We're going to talk about off-grid today, right?
We're talking about off-grid. Off-grid is a very popular topic that everybody wants to know about. And our topic is yes, we can do off grid. I know everybody wants to go off grid sometimes, at least that's a thought that a lot of people have. But what I wanted to ask you is this is the number one question that I get in my job right now. And this question that people ask me, I want to know if you get a similar question asked to you on a regular basis. And the question is right here: what size solar system do I need for an off grid application?
Well, yeah, so first, let me just say that most off-grid customers, for the most part, aren't doing this by choice. They're doing this by necessity. Rarely are you going to go off-grid or just specifically go without the grid in general, unless you absolutely have to, or it's just financially not practical to connect to the grid. And so that the question that you have is absolutely, it comes up all the time. It's I got a 2,000, 3,000 square foot house. How much solar do I need? Well, I mean, realistically, your 2,000 square foot house and my 2,000 square foot house don't consume the same amount of energy. So this is a topic that basically transitions you into doing load calculations. So we have to know how much energy on a daily basis you're going to consume so that we can calculate how large the actual system needs to be. And I mean, generally there's going to be, several aspects of a system that need to be calculated based on that amount of energy that you're going to be consuming.
So how would a homeowner go about selecting loads? Like what does that look like? What type of decisions or questions should one ask themselves when selecting a load?
Well, okay, so if you're going to go off grid, there's some loads that it just really doesn't make a whole lot of sense to have. And then there's ways to optimize the house so that it becomes as electrically efficient as possible and ultimately thermally efficient. In general, you want to make, if you're building a house from scratch, from ground up, and you're going off grid, you really want to choose the appliances that you're going to have in that home, as well as design the home around the appliances. So it's not just a matter of like sizing a solar electric system to suit a home, because there's various design choices you can make when you design the house that will make significant impacts on the scale of the off-grid system, and thus the upfront cost of that system. So things like an electric range, an electric water heater, everyone thinks, well, I'm going to go off grid, so I want everything to be electric. Well, that's fine. You can do that. I have a lot of clients who go all electric, but the scale of the system can be 2 or 3 times larger than if you, for example, decided to go with like a gas range, like LP, and an instant gas water heater and stuff like that. So there's several choices that you can make on the appliance side that will scale the system. And then in general, as far as calculating loads, once you've kind of got like an idea as to what you plan on running off the system, in a normal house, you're going to have, lights, several receptacles, various like minor appliance loads, computer, that kind of stuff, coffee pot. But the big stuff really makes the system change quite a lot, like electric water heater and stuff like that. So it's not to say you can't have an electric water heater as kind of a dump load or an auxiliary like reserve to set unused energy into, but calculating the loads really is more than just adding up, you know, what you're planning on putting in the house. You really want to think about what you're going to do there.
So when someone goes off grid, you had mentioned the fact that they're not doing it of their own volition. Typically, there's usually a reason that they can't get
Well, I mean,
electricity, and or
yeah, but like,
sometimes.
yeah, like, so I mean, if you're going to buy a piece of property that's off grid, chances are you're going to know it's off grid, right? So you are kind of doing it by choice,
Right.
but it's not necessarily like, it's not necessarily a choice per se. Like,
Right.
there's
Right.
not necessarily two options, because usually if you have the grid, that's like my house, right? Just give you an example. Like, I live a nearly in my opinion, a nearly sustainable, like electrically sustainable life. My entire house, for the most part, is ran off solar and batteries. Okay, but I have the grid. Like, I don't completely disconnect from it. I keep the grid as a backup generator, and that, in my eyes, is kind of off grid. But realistically, I still have the grid. There are, and that can be considered a grid, like, exclusive
Okay.
situation. But real off grid is like, there is no grid. You either make your energy sustainably with solar, or you offset your lack of production with a generator. There is no grid, right?
So when someone is really deciding to go with solar in general, and they want to make that decision to go off grid, the size of your house is not important, but what's more important is the loads that you're going to select. So in essence, a consumer needs to decide what they deem important, what they want to actually run. Now, in northern Arizona wind and sun, if I know what I want to run and I have an idea of what I would like to do, can you guys help somebody calculate their loads?
Yeah, of course. I mean, we can help add them up, but we do more than that. Like, I've been doing this for a long time, and I have a lot of insight into how the general consumer of energy is going to use their energy. And I mean, I've done projects from, well, all over the world: South America, North America, Africa, like all over the place. And I mean, we can help calculate the amount of energy you're going to consume, but it gets more than that. We can help you with design ideas, implementation, the design ideas as far as how you're going to implement the entirety of your system, not just the electric, but like various concepts that are going to make a major impact in the performance of your system down the road.
So you guys are like soup to nuts.
Well, yeah,
You help with the.
I mean, obviously our main goal is to put together, like, take your problem as far as, you know, designing the electrical system for your house, and try to put together a reliable and robust solution that's going to allow you to power your off-grid home, or your grid exclusive lifestyle, right? So like, that's our specialty. I mean, we do grid tie, and we do all sorts of, like, grid tie with battery backup and stuff like that. But our specialty is off grid. That's what our forte is. And we can get you everything from, you know, the panels and mounting, the inverter system, the batteries, the interconnect, all of that, so that you can integrate this into your project, and with your project, to, you know, be comfortable, to get you what you need and help you size that system.
Okay, so this is my next question for you. What are the four main components of an off-grid system? If someone says, "Hey, I saw this today. I want to explore going off-grid with solar," what are the four main components needed to accomplish this?
Right. Okay. So the main components are usually going to be, well, the obvious is the solar panels. Like, everyone thinks like, it's solar. It's a solar electric system. So definitely the solar panels. Typically, you're going to need something that you're going to use to mount the panels. This could be considered maybe an accessory to the panels, but it's kind of an important consideration, because there's a lot of different ways to mount panels. And then you're going to have the inverter system, or I guess the energy management system to some regards. So you're going to have the inverter system and the charge controller, which manages the solar power, like the whole power system, and then you have the batteries. The batteries are obviously one of the most important parts, as well as the inverter and the solar, because as a whole, it all comes together to produce, deliver, and store the energy that you need.
So let me ask this question. A lot of times someone will ask me, I already have an inverter. I already have an inverter in my system, but I want to add batteries. So what is the difference between a PV inverter versus what we call a hybrid inverter for that you add batteries to? What are some of the differences there?
So I guess you're referring to like a grid tie sort of inverter, like a string inverter or microinverters versus a
Yes.
battery-based inverter.
Yes.
Okay, so well, conventionally, like a regular grid tie inverter is just specifically designed to take photovoltaic power and invert it to deliver essentially to the main panel and thus to the grid. So they typically don't have any interaction with a battery bank. There's some, I guess we would call them kind of a hybrid solution, which is basically like a battery-based inverter that can do that as well, like Solarc or the Skybox from Outback and a few others, where they essentially can just straight invert and deliver to the grid, but also interact with batteries. But primarily for off-grid applications, you're going to need a battery-based inverter charger. Now, it can be a hybrid solution in some cases, or it can just be a standard 48 volt or 24 volt, or I mean, most people aren't going to do a 12 volt, but inverter charger. And depending on how you want that product to deliver is going to really kind of determine which product is best for your application. But an inverter charger, specifically a battery-based inverter charger, is what you're going to need for an off-grid application.
Okay. So my next question is, when we go off grid, how important is the inverter selection in an off grid system?
Well, it's quite important because that's what delivers the power. So as the consumer of energy, you're also instantaneously consuming power. And that power is a super dynamic load, right? It's like loads are very dynamic. Kick on, kick off. You turn things on, you turn things off. And you really want to make sure that the inverter is paired with your system design adequately. So, I mean, it doesn't make sense if you're going to be drawing really high amounts of power to have an inverter that's really small. It's just going to cause you major problems. And it doesn't make sense to have an inverter that's super large or super scaled up for an application that's going to have, low power draw. And so it is absolutely an important consideration to size the inverter perfectly to suit your application and to make sure that possibly is a dynamic solution so that as loads increase, for example, as you expand your home or you add more appliances, you can possibly add more inverters to work together to power higher demands. So it's a super important consideration.
Now in off grid, what is the primary battery chemistry seen in off grid? There's a couple battery types out there in the market. When I'm saying types, I'm talking about just physical chemistry types. What primarily do you see in off grid applications? What are the main battery types?
Okay, so I mean, the primary chemistry, I mean, you really have three primary chemistries or common chemistries, maybe four, but really the most common is going to be, well, I guess it kind of depends on where in time you look at this. So in the past, the most common was like lead acid. They've been around for 100+ years. It's a known chemistry and it's relatively reliable and safe. But conventionally nowadays, most people are going with lithium. This is obvious. This is why we're having this conversation. But lithium is a significant contributor in modern system designs. I would also say that you have nickel iron batteries, which kind of, I mean, they're there, but I have reservations about them. And you have cadmium batteries, nickel cadmium batteries, which is like an AGM, like a maintenance-free solution that's, you know, not as prevalent. So, but by far the most common this day and age are lead acid and lithium, and specifically lead acid is being flooded or AGM, and then obviously lithium iron phosphate chemistry for, you know, modern system designs.
So if I'm hearing you correctly, batteries have been around for a while, because just listen to what you're saying, the evolution of batteries. Batteries has been around for a while in solar design. And my question is this: so lead acid, you mentioned AGM style batteries, you mentioned the lithium battery. What are the main differences you see between lithium versus your lead acid batteries?
Okay, well, okay, so the easiest way to describe this is based on the limitations of various solutions. All right, so I mean, the biggest obvious difference to a lot of you know, customers up front is going to be the difference in cost, right? Well, you know, lead acid, AGM, lithium, there's a pretty significant variance in cost associated with, you know, the battery chemistries, or at least the battery types. However, there's significant advantages going with different options. So if you're just putting together a system, you know, you have a minimal budget, for example, and you need a reservoir, then lead acid's probably going to be your first, like the first thing you look at. But there's potential issues with flooded lead acid batteries. For example, they off-gas hydrogen. They're caustic. They suffer from partial state of charge. They cannot be expanded. And that same goes for AGM in the sense that they can't be expanded. AGM is a little bit more expensive, but it's a maintenance-free solution. Depending on the chemistry, like the actual delivered solution, they may or may not suffer significantly from partial state of charge. But, you know, at least they're a maintenance-free variant of a flooded lead acid battery. And then you have lithium. And the reason why a lot of our clients nowadays are kind of moving towards the lithium solution is because of primarily scalability and depth of discharge and lifetime cost evaluated, right? So in the scheme of things, lithium batteries tend to be the most affordable solution in the long run. They can tolerate massive amounts of abuse. So like anybody that's getting just into an off-grid system, I can almost guarantee you go flooded lead acid batteries, you're going to end up, I hate to say it, but destroying those batteries well before their end of life. It just happens. Unless you baby the batteries constantly and worry about them and just constantly take care of them, you're going to destroy them. With lithium batteries, they have an internal battery management system. You are hard pressed to usually damage them from abusive behavior. And even myself, like I've been doing off-grid for a long time, the off-grid system design for almost 8 years now. And on my system, I've taken my batteries, well, I call it graveyarding, on multiple occasions. Complete BMS shutdown. If that was a lead acid battery, I can check off a year every time I do that, basically. With the lithium battery, it's a solution you just don't have to stress about. If it over discharges, you recharge it back up. It's not a big deal. And ultimately, the biggest advantage that they have is that they're expandable. And so every aspect of a system, if it's designed correctly, as we talked about, the 4 primary components can be expanded except for the batteries unless you go with lithium. So you can add more solar panels, you can increase your power management system by either adding more inverters or adding more charge controllers. You can add more batteries only if you go with lithium batteries. I mean, that's not to say you can't add more batteries if you go with lead acid, but best practice dictates you shouldn't. And so that's why lithium is really common in this day and age.
So when you say about adding to your system, so if we had a lead acid battery, is the reason why you can't add to that, or it's not highly recommended, is because of the degradation of the battery? Is that part of the reason why they don't recommend adding
Yeah,
to
they
the lead
negatively
acid?
affect each other.
Okay.
So, I mean, ultimately, your goal when you have a battery bank is to get as much life off the battery bank as possible. It's a sunk investment, and it's just depreciating constantly, right? Anytime you use it, it's degrading. If you add to lead acid batteries, then essentially they negatively affect each other, and you ultimately end up with even less life on both of the battery banks. And so it's a negative, it's even more of a negative investment, right? So ultimately what you want in a system is to get as much usable energy off of the battery bank as possible so that you can minimize your unit cost per energy, right?
So when you're designing the off-grid system, I guess you got to have two approaches then, because the one is cheaper upfront, and the other one is cheaper in the long run, or less expensive is a better word, I should say. So when you're evaluating designing a system and you're looking at the cost, the lead acid adds maintenance, where the lithium doesn't have the same level of maintenance. In addition, you said that you can add to the system. Now, you did mention something that I wanted to explore. Is there an advantage to having a battery management system in a battery?
Well, it's imperative with respect to lithium, but let me touch on something. So one shouldn't design a system based on cost. When we look at a customer's problem, and we're trying to derive a solution, our goal is to drive the best solution. If we have to, tailor that solution around some other conditions, then we can do that. But ultimately, designing the best solution is the utmost importance. And so I mean, there are going to be different things that will drive a particular way of doing things, but it's not about cost. It should never be about cost. I mean, of course, everyone has a budget, but when we look at something, we look at it like the best way to do this is this way. All right. So that's what one should consider, and then, redesign or retailor the solution based on limitations. As far as batteries are concerned and BMSs, it's imperative that a lithium battery has a BMS in my eyes. That's what makes it such a robust solution. The fact that the battery management system can monitor the lithium battery internally and essentially say no when the battery is getting to a point where it could be damaged. So in a conventional system with lead acid batteries or whatever, you're relying on the inverter system, GenStar, something to step in if the batteries are getting to a point where they could be damaged or significantly damaged, okay? With a lithium battery, that is done on the battery level. And that is a super important consideration, considering lithium batteries, if you overcharge them, are immediately damaged, essentially. And if they get over discharged on the cell level, they're immediately damaged. However, if the BMS is there, then it'll prevent one from overcharging because it'll just nope out the battery. And it'll basically prevent one from over discharging because it'll just nope out the battery. Basically, the battery gets to the point where it's over discharged, it just says nope and disconnects. And that's kind of an important thing with a battery with a significant upfront cost, but you're getting more advantage to the system that way because you're really pushing those. Ideally, you can push the batteries to the limits. Like I said, I take my batteries on multiple times, sometimes intentionally push the system to its limits, see how much energy I can get off my system. And it just nopes out.
So the battery management system is really like a fail-safe in essence. It's allowing you not to damage your system. And now you said
Mhm.
taking the batteries to its limit. So in the lithium battery game, you always hear the words depth of discharge. That's a
Right.
very popular word, depth of discharge. You hear another thing on cycle life. What do you see in terms of depth of discharge and cycle life with lithium versus your lead acid batteries?
Well, yeah, I mean, there's the manufacturer's defined depth of discharge, and then there's realistic depth of discharge. Now, I mean, I think I've been selling lithium batteries for about 5 years now, so I'm about halfway through what manufacturers say is the usable life of a lithium battery. I have yet to have a customer come back to me and have to deal with a situation where a battery has failed. It's still functional, but it's failed premature of its cycle life. On the other hand, with lead acid batteries, their cycle lives are highly dependent on use and abuse, and any use is abuse. So, and the amount of use really is, the scale of that abuse. So the cycle life of a lithium battery or of lead acid battery is really, it's really hard to like quantify because it's affected by temperature, proper charging, proper discharging, not over discharging. Recharging is super important as well, like partial state of charge, not properly fully recharging. Like these characteristics all have a major effect on the cycle, like defined cycle rate of the lithium or the lead acid batteries, as well as the battery ages, its internal resistance gets higher and higher, and so it becomes harder and harder to achieve certain considerations that will affect the life. So you get a situation where it's kind of diverging. With lithium batteries, they don't have a lot of those negative characteristics that can reduce the cycle life. They're not affected by temperature typically. I mean, they kind of are, but not nearly to the extent of a lead acid battery. They have a major cycle range. And so if you design a system properly, in most cases, you can get more or a significant more cycles realistically from the battery than the manufacturer even says, because they're basing it off of a specific depth of discharge or whatever. And realistically, most off-grid customers don't hit those depth of discharges every day because the amount of energy one uses varies quite significantly throughout different days. Anyways, so yeah, cycle rates, there's a huge difference between lead acid in AGM solutions and lithium because these cycle rates over here are majorly affected by a lot of factors that one might not have a ton of control over, or aren't very obvious all the time. In this particular solution, lithium, it's not it doesn't really care about most of the external factors, doesn't even need to be fully recharged regularly. So there's not a whole lot you can do to negatively affect the cycle rates, right?
So when we look at lithium, we look at lead acid, those are the predominant battery choices that we see in the market, and people will make a decision based on their particular needs. As you said, costs really shouldn't be the issue when we're designing a system. We should design the best system, and then we can kind of back into the cost. So let me ask this question, because if I'm off grid, let's say I'm totally off grid or totally island away from utility, is it
Mm-hmm.
important? What type of redundancies should I have to support my off grid system? Because I'm imagining if I don't have utility power and I just have my PV array and I have my battery, what else do I need?
Yeah. Well, I mean, realistically, if you get 365 days of sun, you don't need anything. But unfortunately, depending on where you're located, that might not be the case. And so typically, I would recommend one has a backup generator of some sort, a fuel derived generator. You can get a wind turbine as well to help supplement. But ultimately, as far as, an auxiliary input to the system besides the solar component alone, some other form of manually or fuel derived power generation is ideal. So I have a lot of customers who have wind turbines and hydraulic turbines, and they help supplement some more than others. But ultimately, an off-grid system is really going to want to have a generator, and that's why the inverter selection is kind of important as well, because most, well, if not all, off-grid suitable solutions will have, they're basically inverter chargers. They have the ability to run in reverse and recharge the batteries back up. So from a generator, from an AC input source.
So let me ask this question. We're getting close to our time, but I really wanted to ask this question. So
Okay.
what is the difference between, I hear this all the time, charge controller, and then you said inverter charger. What's the difference? Is there a difference? Like, is there a charge controller? Then I still need an inverter. If I have an inverter charger, do I no longer need a charge controller? Explain that when someone's designing a system. What does that really do? What does the charge controller do? What does the inverter do? Can you explain that?
Well, okay, so an inverter inverts. So it takes power from a DC source and inverts that to make the AC output. It can be 120 volts, could be 12240, could be configured to do three-phase, 230 volts, 480, whatever. Like, there's all sorts of different solutions, but an inverter will typically take a DC input and invert that to an AC form factor. All right. A charge controller specifically refers to how we manage, in a DC coupled solution, how we manage solar power into the DC bus and thus inherently to the batteries. So charge controllers basically go with the solar panel. Inverters and inverter chargers invert and deliver power to AC loads, as well as convert the opposite in the event they're being fed an AC input from either a generator or also the grid, potentially for grid interactive solutions, to charge batteries. So both charge controllers and inverter chargers can charge batteries, but only inverters can pull power from the batteries to deliver to loads. And you will most likely need both, unless you get like an all-in-one solution that has that solar charging component built into it in some manner. And there's several products out there that have that. Or there's several systems that you can get that have both the inverter and charge controllers kind of on one system, and pairing an array with the charge controller and the inverter with your loads is kind of a key to selecting that kind of solution.
So in closing, yes, we can do off grid. So if someone wants to go off grid, they're gonna need the main components of your solar array, some type of charge controller, inverter. Then we're gonna have a battery. Also, it's recommended if you're totally off grid to have a level of redundancy to support your installation, because as you said, you don't always have full sunny days. Now, I want to ask this final question. What got you into solar? This is going to be our part. What got you into solar? This is this is not a canned question, so you didn't have a chance to think about this. So this is off the cuff, Michael Gibson special. What got Mr. James Hall into solar?
Well, solar kind of fell into my lap. I've been doing it for quite a long time through college, and my original endeavor, I guess, was I specifically was designing standalone systems for a variety of different small load applications. This obviously got me familiar with DC coupled solutions, solar, charge controllers, batteries, and a variety of scalable loads. And I lived in Florida. That's where I was. So we had lots of distribution into the Caribbean and throughout the United States and Europe. And then I transitioned into specifically designing and specializing in large-scale off-grid systems. So scaled up significantly. And basically what got me into it is, well, it just fell into my lap. Like I didn't choose solar, it chose me. But I like it. This is my passion. This is what I do.
You didn't choose solar. Solar chose you. I like that. I
Yeah.
like that. I like that a lot. Well, James, I definitely appreciate you coming on our show and being a guest. And what do you see? I guess this is my final question, right? My final question.
Final?
Final. You know what I mean? That means I'm serious. Final. I'm coming in.
All right.
What do you see for off grid in the future? What? How do I want to say this? In the future, off grid, we know where it's at. What do you see as the next step in off grid, just to making it better, more robust? What do you see for off grid in the future?
Yeah, I don't know. It's hard to envision because I mean, if you look at the way systems have transitioned in the last 10-ish years, probably, the most innovative solution pre-lithium was the MPPT charge controller. Like that revolutionized solar power delivery into a system.
Now you just said
Um,
big words. You just said big words. I mean, MPPT. What's that? Break that down for some people that don't
that's
know.
so yeah. So maximum. So I mean, basically, this is us to go back to charge controllers, but there's two variants of charge controllers. You've got PWM charge controllers, which are basically tying a solar array directly into the batteries. It's kind of an older way of dealing with power. And then you have MPPT charge controllers, which are maximum power point trackers. And they're a much more sophisticated, basically buck converter that is super efficient at delivering the maximum amount of power the solar array can produce into the DC bus, to the loads and to the batteries. So maximum power point trackers, they were, they probably realistically started taking off about 10 years ago. And then about 2-3 years ago, maybe my time's a little bit off due to how crazy the industry's been in the last few years. But lithium just started like going nuts. I mean, there's a huge amount of advantage to it. What's next is really hard to put a finger on. I think commonly in the industry, a lot of manufacturers, as far as inverters are concerned, have all been using low frequency switching, toroidal or transformer based inverters. I think there's a slight transition to going with high frequency switching inverters, which are common in grid tie. So that might be something to keep an eye on, or maybe even high voltage DC battery banks and inverter equipment to do off-grid. It's really hard to see. Maybe there's going to be a new generator out there that'll help supplement solar input, like a whole new technology there. We'll all have to just see. And being that I sit in this industry, I'll see it first. But yeah, I look forward to seeing what happens in the future as far as innovation is concerned.
Well, the future is definitely bright. It's definitely bright in this industry. And again, I really do thank you for your time, for chiming in and just hopping on and being a guest. Sorry for taking you a little bit over time, but I really just enjoyed the conversation. And James, thank you for joining in. And you've been watching Secure Your Energy Show. I'm your host, Michael Gibson. And if you would like to be a part of the Secure Your Energy Show, you can go to bit.ly/Secure Your Energy Show to get a spot. And also, it airs bi-weekly at 11 a.m. So bi-weekly on Wednesdays at 11 a.m. is when you can view our show. And we do thank you for viewing. Please share and also follow.